So again, just like question 13, but this is definite integrals. So that we need product to sum, sine 3x sine x. So we know sine 3x sine x is the same as half cos of the subtraction minus cos of the addition. And it's a definite integral between 0 and pi on 4. So again, we can go straight ahead, just be a little bit careful here. So cos goes to sine. Of course, we need to divide by that 2. And I'll just put minus a half out the front here. So cos 4x goes to sine 4x. And we're dividing by 4 here. And that's between 0 and pi on 4. All right. So if I just put that half out the front, let's have a look at that. So when we do sine of 2 pi on 4, which is pi on 2, we would get our 1, and sine of 2 zeros is the same as sine 0. So we're getting 0 there. If I put the 4 with the 2, so I've got 1/8 out the front. 4 times pi on 4 is pi, so sine pi is 0, and 4 lots of zeros is 0, so again we get 0, so actually that disappears and we just get the 1/4. Okay, let's do the same thing for B. So this time cos, so using our formula sheet, we are going to change that cos. So product to sums, we will get a cos of the subtraction, 2x, plus a cos of the addition. So we get cos 2x plus cos 6x. So again, if I put a half out the front, I can go straight ahead and integrate. So I've got sine 2x on 2. I'm going to do that separate. So again, I'm going to put a half out the front. And here I've got sine 6x on 6. So again, if I put that 2 out the front with the half, I've got a quarter. Sine of 2 pi on 4 is pi on 4. So again, we've got 1 and sine of 0 is 0. Put that 6 out the front with the 2. So I've got 1 on 12 out the front. Here I've got 6 pi on 4. So 3 pi on 2. So 3, so 1.5. So I'm going to get a -1 here. I can think of it as well because it's a nice angle. You can also just think, what does the sine curve do? It goes like that. This is 2 pi, this is pi. So 3 pi on 2 is here at -1. So I've got -1, then I put 0 in. So here I've actually just got a quarter minus 1/12. That'll be 1/6. All right, so the last one is a sine cos. So for a sine cos, let me just put it here. All right, sine 4x cos 2x. So we're going to get a half of sine, so if I do the addition and then the sine of the subtraction, and it's a definite integral between 0 and pi on 3. So I keep that half out the front. Sine 6x goes to negative cos 6x on 6. I'm going to keep that a half again. And here I'm going to get negative cos 2x on 2. All right, so if I do put the 6 out there, so 1 on 12, and to take care of that minus, I'm just going to substitute in the opposite order to what we normally do. So I'm going to sub the 0 in first. So cos of 0 is 1 minus, now I'm going to sub the pi on 3, and so it becomes 6 pi on 3, which is the same as 2 pi. And remember our cos curve at 2 pi is 1. So I get 1 minus 1, so that's actually going to cancel. Putting the 2 out the front, and again, just substituting in reverse order to take care of that minus can sometimes be easier. So again, here we've got cos of, is that supposed to be a 2? Yes, that's a 2. So 2 0 is 0, so we're going to get 1, cos of 0 is 1. And then I've got 2 pi on 3 for cos. So I'm going to get negative minus, and then I'm going to get negative a half, aren't I? So 2 pi on 3 is, oops, if we go, so it's over in this quadrant, all stations, so cos we know is negative, and then we can just use the pi on 3, which is 60, so cos 60 is a half. So let's see what we get here. So the first term disappears, and the second term is, I've got a quarter lots of 1 plus a half, which will give me 3 on 8.